Hi guys, so this video is due on Thursday. We are connecting the different representations of functions now that we know what a function is. Alright, so you can represent functions in 3 different ways. For example, let's take a look at this scenario. So here we have our scenario. A day at the amusement park costs $10 for an entrance fee and $2.50 for each ride. So we can represent that as an equation, as shown here. You should be familiar with that from last unit. We can also represent it as a table. And lastly, we can represent it as a graph. So over the course of the rest of this unit, we are going to be looking at functions not only through those mapping diagrams and the tables, but we are going to look at them all of these different ways. So last unit, we've zoomed in and only looked at linear functions. This unit, we're both going to look at linear functions and nonlinear functions. All right, so what is the difference between those? Linear functions, I'm going to draw a sketch. Linear functions, as we saw last unit, are always going to be straight. All right. They also have what we're going to call a constant rate of change. And that's the same thing as slope. Now, last unit I told you to find slope, but this unit we're going to see if it has a slope or it doesn't. If it has a constant constant rate of change, then it is linear. If not, then it's nonlinear. So nonlinear functions can look like many things, but the main part of it is that they are curved. All right, they are not straight. Okay, which means if they're not straight, then they do not have a constant rate of change. Okay, so when we are doing these problems, we first want to ask ourselves, one, is it a function or not? And if it is a function, then we're going to identify if it's linear or nonlinear. Right? If it's not a function, then it can't be linear or nonlinear because those are only functions. So that's got to be the first step. So let's take a look at this example. Each week, Darlene tracks the number of party hats her company has in stock. Is this relationship a linear function? Use the table or graph to support your answer. All right, so first thing I'm going to check is it even a function? All right, and how do we do that? That's what we went over in the beginning of the week. We do that by looking at our x values, and in this case, our x values are w, and I can tell that by this axis right here. And I see that no x values repeat, so that means it is a function. Yes, because every input or x value has its unique or own y value. Okay, so now once I've answered that, I can now ask myself, is it linear or not? And I can do that by either looking at my table for a constant rate, but since they give us a graph, let's take a look at that graph. And let's plot these points, and we can see, is it a straight line or not? So I'm going to plot the point 0, 300. That goes here. The next one's going to be 1, 250. That's here. 2, 200. 3, 150. 4, 100. 5, 50. Okay, so I asked myself, does it form a straight line? Yeah. I can also see that this is decreasing by 50 every time. That means it does have a constant rate because it's adding or subtracting by the same number. So this is a linear function because the graph represents a straight line. All right, and we'll practice this more tomorrow. I just wanted you to get the overall idea. If you have any questions, please make sure to type them in at the end. See ya.